all the controls are switched off. It shows that all the lines or all the cables are in the grounded position.
Okay.
The Teleflex screen is off. Okay.
So we need all that one two
Yes.
breaker
The breakers that are controlling all these circuits are
on.
on.
The first one
now.
is the main.
Yeah. So what we do? So we start by pressing the
Yeah.
on button. Okay, now it tells us that we need to select the mode, the phase
Yes.
and parameters.
So we'll
However, we will not conduct any of the tests mentioned here because we will do the low voltage TDR first.
Okay.
So we power up the Teleflex.
Okay.
So we give it a minute or so just to boot up. And then we will see what we can do. The test leads are already connected to our sample cable,
Yeah.
and we have already conducted insulation resistance measurement as well. Okay, so this is the starting screen. Always starts here. So like I said, we will begin with TDR. So we select the function. There's a button next to this position which says TDR. I select it, and automatically line 1, the light becomes on, and then I have the basic information about the test parameters. So line 1, the length setup on the TDR, the position of the cursor and the reference, then below it is the speed at which our pulse travels in the cable. It shows 80 meters per microsecond. This is the standard value, and it's in line with the setting for XLPE cable.
XLP.
Yes, which should be 80 meters per microsecond.
Okay.
The gain is the it's like a multiplier which tells us what is the amplification of the signal that we are seeing on the screen. Okay, with this particular amplification we can see the whole pulse on our screen, which is sufficient for the further analysis. Then on the X range, this is how far we can see into the cable. We know that the test leads of the van have a length of 70 meters, so 70 meters of this trace shows us what is happening with our test leads. We are not really interested in that, so that means that we need to extend our view further into the cable. So I press a button next to the X range, and I select a bit wider section of the cable. At the moment our range is set to 160 meters, which is sufficient because we know that our sample cable is only around 30 meters long.
Okay.
Okay, so what can I do now? Well, we have the method of operation which is set to reflection. Okay, if I press it to difference, it shows me a difference between two different pulses or two different measurements, but we have not conducted another measurement, so this trace is flat. So let's go back to reflection. Then other mode of operation is the measurement. We know that we have just a single conductor with concentric neutral, so our measurement is set to line to neutral. The other option is line to line, but we have no other line here.
Okay.
We have single line only.
Yes.
Always.
Then memory allows us to save and load traces that we have just taken or recall them from the past. And then active and stop. Okay, this means that we either have a continuous measurement or we can stop in a particular moment and freeze the screen. Okay, so let's go back to active. TDR mode. Okay, let's select TDR mode. We have single trace, continuous and average. Okay, single trace is this, as you can see, continuous. We will see the screen blinking, which means that the TDR sends the pulses continuously into the cable. Okay. At the moment we cannot really see any added value to what we have set up previously, so we can leave it like that. Then the Teleflex menu, what we have inside. So we have again access to the gain, we have access to the filter, to the trigger level, and you can select the traces to be displayed. Pulse width, this can be changed, at the moment it's 200 nanoseconds. Then the X shift can be permanently set up here, the compensation, and the speed of travel of our pulse. Okay, like I said previously, we have XLPE cable, so we don't need to play with this setting. Compensation and filter is automatically changed depending on the pulse width. So we set it to 200 nanoseconds, which is at the moment sufficient to conduct our measurements, so we'll not change anything. Okay, so let's return to the previous screen. Okay. What is interesting about this trace is that because of the very short length of the sample, we cannot really determine where is the end of this cable. Okay, it's not easily and clearly visible.
Mhm.
Even if I change the X range to longer pulse, I still cannot clearly determine what is the portion of the
end,
cable where the pulse bounces back to me.
Mm.
Okay, there is no visible tip-up. Somewhere at 300 meters probably, the signal just comes back on itself and is zero again in amplitude. Okay, this is unfortunate that we cannot really determine where is the cable end here, but we can tell where is the fault. Okay, luckily. Okay, let's leave it at 120 meters. Okay, so based on this, we know that our measurement of IR showed that we are dealing with high resistance fault, and that means that low voltage TDR is not capable of detecting the fault location. Therefore, we need to change our mode of operation and try different method of pre-location, and that will be the arc reflection method. Okay. Oh, so maybe while we're here, let's show how to play with the memory. Okay. So what we can do, we can move this trace to memory position 1, okay, or we can save it to another location. We can delete display, so clear the screen, or we can load other traces or delete them from the memory. So let's try saving this trace. So we place the button, then which trace do we want? We have only one, so no choice really. Then using the cursor knob, we scroll down to next available position, 21, and then select selection done, and it is saved here. Okay. As like I said before, we cannot really determine what is happening with this cable, so we will move to another method. Let's press return, and we are back in the main screen. Okay, so our available method is the HV methods. Okay, and this is the ARM. So if I click on this, okay, there is at the moment nothing displayed on the screen because the ARM method is not selected on the upper control panel. So we will do it now. Okay, so I press ARM, waiting for it to activate. The flashing light, the blinking light will change. Okay.
Started at 0.
We can select the line
Mhm.
to be tested. So from grounding position, it comes to the active position. Okay. Now we have a message saying turn HV on. Okay. So there is a button here.
Yeah. For its
Okay. And it says that ARM is on. Excellent. What changed on the screen? At the moment, nothing changed on the screen because the main surge unit is still not connected to the system. Therefore, the system is not sending any pulses into the cable to collect the reference data. The light on the single pulse is blinking, which means this is ready to be used. However, we will not send anything because this is not activated. So let's proceed with the activation. So switch into on position, activate, and then we set voltage level, say 4 kV. Okay, now about the screen. So
You have a reference to this.
yes, we don't have the reference yet. Yes. So what we do? Our gain is set to -19. We don't know whether this is sufficient or not. So let's do the reference. Yes. Okay. So this is what is coming back from the system at the moment. This is probably not sufficient, so we need to extend our range. Okay, that's a bit better. Okay, we set the range to 240 meters, which is well above the length of our
cable.
system under the test. Yes. The peaks are a bit small, so we can change the gain maybe to a bit lower, so we will see more details on the screen. Okay, at the moment it's minus 14 dB. Let's check. Okay, this is our reference.
Cursor.
The cursor,
70.
we will move it to 70 meters
Because our
because this is the
Our
length
cable.
of our test leads.
Yeah.
Yes.
this cable.
Okay. It's around 70 meters. Okay, so anything beyond this point, this is our cable. Okay, so we can click the knob or push it in. That sets the
That
this
was zero
position
there, huh?
as a starting position or
Okay.
reference position for the further test. Okay, so I think we are set up for the collection of the fault trace. Okay,
Yeah.
so we will move now to press this button to change to fault. Okay, single only. We have our surge unit set, so let's send a pulse. Who is going to shout?
Clear?
Okay, so we send the pulse. Is the blue line displayed on the screen now, and we can clearly see where these two lines, the reference trace and the fault trace, are departing from each other. So if I select the cursor and start moving it, this is at the reference point
Mhm.
now. So now I'm going into my cable. So the point is around 27 meters away, or 27 meters into the cable, which matches with the area that we have introduced the fault into earlier this morning. Okay. We have we may say that we have successfully located the fault,
Fault.
but this is just the pre-location. Okay, now for
Yeah.
the pinpointing, we need to move to the next step, and for that step probably we can finish this video and